All right, so I'm going to talk about a project that I wrote. It's a piece of software that allows you to try and play with neurofeedback at home on open source hardware. And I would like to start with first by telling you why I think that open source software is important and why I think that we need to experiment on ourselves, so the sample size of 1. I think that a lot of us think that other people, what they have inside their heads is similar to what we have, which is, I don't think, very true. I think if we were able to experience inside of any other person's head, we would be very surprised how different it looks. And what science currently does is that it measures some variables and then build some conclusions. And I think that because we are different, what is actually very important is what works for us. And what works for us might be very different to what works for 10,000 other people in some kind of study. So I think this is very important. There are other important things that I would like to mention, but first of all, just remember ourselves, let's say 20 years ago or 10 years ago. And I don't know if I would even go and have a tea with myself from 20 years ago. I'm such a different person. So imagine how all the other people are different. I come from a hacker background, and I like biohacking, so changing my biology to become better. I'm not looking to treat depression or diseases, because that's not what I'm good at. I'm an IT guy, so I'm not going to tell you how to help people with diseases, because I have no experience in that. I think that open source is very important, and science is kind of opening more lately. There were a lot of people, even at this conference, who said that they are sharing the data. So I want to tell you from the open source world that sharing the data after you collect it and processed it and published it, that's not open source, that's just publishing. Open source is when you want to increase the pace of innovation. So an open source mantra is called release early, release often. So when you have data on one person, you put it outside and you allow people to build on it immediately. So you publish everything all the time. So when I'm playing with my software, I make an improvement, you can try it the same day because I commit it to GitHub and you can build on top of that. So people often say, okay, but then, you know, my research is gonna be stolen by someone else and so on. I don't think that first of all, I don't think that's going to happen, because the person that cares about your research is mostly you, and most people don't care about it that much. And the second thing is that it's great if someone helps you reach your goal. If someone finds out something that you didn't find out, then they're helping you reach your goal. So we're innovating faster. So open source, I think, is really good because life is short, and I don't like to observe semester cycles and you know, funding cycles and all these things. Peer review, journal publication times, it's very slow. So let's just get rid of the crap and just publish everything that we have. The third reason that I like open source is that it is very difficult to ban and censor information. So if we have a software and open source hardware that anyone can 3D print and build from off-the-shelf components, it would be very difficult to regulate it in any way. So the more people have it, the better. So one case for n=1 is actually when research on psychedelics was not so prevalent because of regulations. We had Arrowit, which published TRIB reports. And I think Arrowit did a lot of great work, because that's actually the place where people look when they want to try some psychedelic. It's not a study of 10 people and their blood pressure and EEG. They want to actually see or read how people experienced it. So I think that it's very important to share all these things. So, first of all, how to become cyborg. Here in Prague, in Parallel Polis, which is the first Bitcoin-only cafeteria and, or currently crypto-only cafeteria and co-working space and things, people started to think about putting NFC chips in their hands, in their palms. Do you have one? Okay, there's a cyborg. The reason was that people were kind of opposed, you know, you don't want to chip people and it's strange and so on. But there were some people who said, okay, I want to try it. It's easy to remove, so why not? I'll just have a chip and I don't know why this happened. And I see how it feels, what are the benefits, drawbacks, and so on. So what they use it is they can pay for coffee or anything using their hand. They can load cryptocurrencies into their hands, and they can open doors and some things. So this adds some kind of feature that you didn't have. So you can actually experience how is it to live with a cryptocurrency wallet and a key. So maybe you can talk to Max about his experience. Another point I would like to make is that we usually think about the body and brain as separate things. And I don't think that it is very true. So our mood, our mind is affected by things like microbiome. When someone is addicted to sugar, they get these weird mood swings, and it's not explained by your thoughts or by neurons, but by different parts of the body. So first of all, I don't think that we can say, let's focus on the brain and scan the brain and just ignore everything else, because that's very untrue. And another thing is that our mind is going beyond our bodies. One of the things is, of course, getting a chip implant, but we are merging with the machines. I don't know, again, if it's good or bad, but we are different people because we have navigation apps, we have Google. So a person from 1,000 years ago has the same brain as we do, but we are much smarter because we can ask questions and get answers immediately. So we use all this communication technology and navigation technology. So I just wanted to make a point that it's already happening. It's not that we are going to merge with the machines. Everyone here, I guess, has a phone and can use the machine to become better, to be smarter, and to communicate, to find your way in a foreign city, for example. So the question is, what if we merged the machines and us in different ways? So, for example, what if we could be able to feel our stress level immediately? What about direct information about our state of mind? So this is going to be interesting, and I'm going to show you some examples on how you can do that. But first of all, I would like to clear some misconceptions about the brain versus computers. So a lot of people say that we only use 10% of our brains. I hope that people would never repeat this stupid thing again, because if we used our brain all of our brain all the time, if we turn on all the neurons, it wouldn't work. That's just, I don't know where this came from, but I think it's just stupid, and it was even repeated on this conference. Another thing is that we think of computers as structural and logical, and us as more intuitive, and of course we have both of logical and intuitive, and so do computers. But if you go to the realm of AI, it's actually very unlogical, and I call it the god of intuition. So when you play with AI, for example, with semantic encoding of words and vector spaces of meaning and so on, you enter a realm where you're interacting with something that is intuitive. So when an AI can tell that there's a dog or a cat on the picture, it won't tell you the reason. It will just tell, I think this is a cat with 98% probability, but there won't be a logical explanation. You know, the cats have ears like this and they look like that. So when we are talking about AI, we're actually interacting with something that is more like our intuition than a program. So that's something that I would like to clear. So let's go to the feedback. Imagine you want to learn juggling. If you would try it with your eyes closed, it would take you a really long time. If you open your eyes and you actually see the balls that you're playing with, it's much easier. And if you can get over the fact that the mirror is reverse, then it's even faster with a mirror. And why is it? Because you have immediate feedback. That means that you can correct all the mistakes just in time. So if a ball is falling here and your hand is here, you just see it and you fix the mistake and move your hand there. So that is why feedback loops are very useful for learning a new skill. And I'm going to give you some examples of how you can do that. First one is very low tech, and that's a simple biofeedback of emotions and their embodiment. So a lot of people, when you ask them how they feel, they don't know how to answer, because usually we don't. We can say, okay, I feel good or I feel bad, but a lot of people won't be able to tell you a specific emotion that they're feeling. And there is a very nice feedback loop between the emotions that we are experiencing and how they feel in the body. So this is very useful, and I do it quite often. So when I feel that something is wrong, for example, I feel that I'm not in a positive mood, I ask myself, where in the body do I feel this? And this way I can learn to distinguish between anger and nervousness or shame or all these things, because they have different embodiments. You can do it the other way. So for example, if you know that if you breathe slowly and regularly, you can change, that's actually embodiment of a different, like more relaxed emotion. You can do it the other way. So you can actually influence your emotions by changing something about your body, so posture, breathing, and so on. So it would be great if we would be able to use technology to build these feedback loops. So first of all, I'm going to show you something about designing new senses, which is really interesting. So our senses are usually always on. So we see all the time. If we close our eyes, we also see the light. So it's not easy to turn it off. And this sensor is actually a compass. So it sends a small electrical signal, so you always know where north is. It's very, very interesting, because the brain can, because of its neuroplasticity, it can interpret the signal, and you actually start integrating it as a new sense. So when you have memories of, so I don't know where North is now, but if I had this device and I would recall a memory of standing here, I would remember the light, the smell, this view of all the beautiful people that woke up early in the morning, and I would remember where North was. I wouldn't remember that it was a signal that was sent, you know, on I don't know, top right corner, but I would remember how I was standing, how I was positioned. You can do other things. So you can, for example, perceive electromagnetic fields. There is a device called elektrosluch, which is Slovak for electro-hearing. You can buy it, and it turns electromagnetic signals into a sound. So imagine walking around a city and hearing a tram coming, and there's a fridge near the kitchen, and all these new things that you didn't even know that you had. So again, if you, it is more difficult to integrate this, because I don't think people would love having this all the time, so it's not a sense that is always on. But what I wanted to share is that you can actually add new senses, and it's very easy and it's very natural for the brain, so they can interpret the signal. So let's integrate biofeedback with senses. The first I like is heart rate variability. Heart rate variability is how regular your heartbeat is, and this is directly correlated with the level of stress. So the more variability you have, the more relaxed you are. So if you are stressed, your heartbeat is very regular, you're ready to fight. And you can actually do a biofeedback on this. I have tried it a few times with a HRV sensor and biofeedback application. And you can teach how to lower your stress level, or increase if that's what you want. This is a very easy way to teach your body how to reduce your stress level. So a very, very neat hack. So if you would be able to have this kind of sense all the time, which I haven't seen before, but it's definitely doable, you would have a sense of your stress level. So you wouldn't need to listen to the embodiment of the stress, but you would actually have the direct information. You can also detect physical stress this way, so adverse reactions to food. A lot of us want to know if some food is good for us or no, or if we have intolerance. It actually reflects on HRV. So if you want to know if you're, I don't know, if you have a problem with gluten or lactose or something like that, is a way to find out. All right, so let's go to the neurofeedback part. So we're combining the open source n=1 experiment. So I didn't put the helmets on many other people. A few have tried it, but not so many. And it's basically my motivation, as you will see later, is to try to create a sense of what my brain is doing. So combining biofeedback and kind of a sense design for everyone to use at home. So what is it? How it works? It measures your EEG signals, so electrical signals in the brain, and it turns them into sound. I use sound feedback because I use it to improve in meditation, and it's better to meditate with my eyes closed. So, but you can do feedback with visual signal as well. And then the goal is that the brain would be able to understand the signal, For that, it needs to be low latency. If there was like, I don't know, 10-second delay, the brain wouldn't connect the relationship between the sound and its internal state. And if the brain understands it, you can use it to train yourself to either increase alpha brain waves, decrease beta, or anything actually that you want to achieve. I like what Heather was saying, that there's not only one state of mind that is normal that we all want to go into. So the way I perceive it, some days I want to be creative, some days I just drink coffee and reply to 50 emails, and it's very different state of mind that is required. So we're not trying to become normal, we're trying to be able to switch between these states of mind. So that's what you can train yourself into. What is important is that when I started with alpha feedback, actually it was more important to suppress the alpha brain waves, and one of the reasons is that it is very difficult to sleep with high alpha. I think it's impossible. So if you don't want to spend hours counting sheep and trying to fall asleep, first thing to learn is how to suppress alpha brain waves. And yeah, so what I use is open source hardware, which I didn't make. I use OpenBCI, which is Open Brain Computer Interface. It's not only EEG device, it's a biosensing device, so you can do also heart monitoring and muscle monitoring. So you can do actually the HRV feedback and everything else. What is good about EEG is that it has immediate low latency feedback in the time domain, but it is not very location precise. You have some electrodes on the skull, but you can't actually measure, I don't know, a few neurons or exact position on the brain, because you are not putting electrodes inside your brain, only on the skull, at least now. With MRI, it's the opposite. So you get very location precise, but it's very slow and inaccurate in time. So that's not very usable for feedback. At least I don't know how I would use it for a feedback loop. And the software I wrote, I will share you the link, but I'm trying, the first project was just turning the alpha amplitude to a low latency sound signal. I use a boring sine wave oscillator, not some music. There are some neurofeedback devices like Muse that play waves and different sounds, but I found that it is very difficult, or maybe with more training I could do it, but I think that the pure sine wave is very easy to interpret, and also I like to listen to noise music, so I don't mind listening to a lot of sine waves, but that might not be pleasant for everyone. And I turn every electrode that I usually use 2 or 4 into a different chord of oscillators. So if I do alpha increase, I try to make as much noise as possible. So ideally 4 chords as loud as possible. Also, you can do feedback on hemicoherence, which is how synchronized the left and right hemispheres are on a particular spot. So that's, I would say, feedback on how integrated your brain is. So my motivation, I wanted to learn meditation, and with meditation it is very difficult to get feedback because everyone is sitting with their eyes closed and you can't really tell if you're doing it right. You can ask the guru and they might give you some insight, but it is not immediate feedback. So I wanted to achieve a state of open mindfulness, the experience of merging, or complete integration. So my goal was to achieve a state of mind where I would just merge with all the senses, thoughts, emotions, and feel everything at the same time without discrimination. So that's one way to do mindfulness. What is also interesting, if some internal conflict comes out, you can see it on the alpha amplitude. So you can't lie to yourself. So you can say, okay, I encountered this thought and it's conflicting, but I'll just pass it and I consider it solved, and it won't work because you need to, it would be very difficult to get an alpha back up. So you need to work through it. So in a way, it is very, I would say, similar to psychedelics. So if you take LSD and something comes up, you can't just say, okay, go away, and then you listen to music again. You can try, but usually it won't work. And this is the same idea. Also, what I found is that if you lose focus, if you start thinking about something and forgetting the merged state, you get immediate feedback. You get silence, the feedback stops, and you know that you need to come back to what you are doing, which is very useful. Because having focus is good for productivity. So if you realize that you were lost on Facebook or in email, it is very good to notice that and come back to what you were doing. The interesting thing is, if you're doing it for a while, you kind of lose the sense of hearing sound, and it feels more like hearing your brain or interacting with your thoughts with what you're doing. So in a way, if you do it, the sense of hearing turns into some other sense of the state of mind. So I'm very interested in what other experiences you can have. I actually forgot one thing. I wanted to show you that this is the OpenBCI board. They also created a 3D model which you can print at home of a helmet. There are 3 sizes. I think that it's, if you can and if you want to try it for a longer time, it is better to use wet electrodes, which connect better. But if you just want to play with it for a while, you can just 3D print the helmet. So it's also part of the project, and I really like that you can create these tools on your home 3D printer or on a printer in a hackerspace. So this is how the software looks like. It's very basic. My part, I have a slightly newer version now, but it's this one. So if you want to do, for example, alpha positive feedback and beta negative feedback, you need to turn on all the frequencies, because then this widget would get only a small band of the signal, and you need all. So that's kind of counterintuitive. I turn off smoothing, so the feedback has low latency and reacts immediately. And then you can then you set cutoff. Cutoff is so when the signal is too strong, it will turn off the sound, and it's because when you move, the signal from the muscles is stronger than the EEG signal. So you would hear a lot of noise, and then you would train yourself in being stuck still, and you would think that you're actually doing what you're supposed to do. And it would be just muscle tension. So then there's some configuration. You can configure hemicoherence feedback between channels. It's up to you how you place the electrodes. The board that is used here has 4 channels, so that's the ganglion board. I also have the other board of OpenBCI, which is 8 channels by default, and you can have up to 16, but then it's going to be a lot of noise. So if you want to do 4 electrodes and hemicoherence, then it's 5 tones, and that's kind of overwhelming by itself. So you can play with the software. I welcome pull requests and all the ideas. You can play with it, and if you want to get in touch with me, you can read some of my blogs and about biohacking and other stuff. So thank you very much.